Okay, Year 10, and welcome to Lesson 3. Figure 1 shows the distance time graph for a person walking to a bus stop. So Figure 1, distance in metres, and we've got the graph going up, flat and up. Which one of the following statements describes the motion of the person between points R and S on the graph? Not moving, moving at constant speed, moving with increasing speed. So between R and S, if you look carefully at R, the person's gone 300 metres, and at S they've still gone 300 metres, so they haven't actually gone anywhere, and that's why I can say the answer is not moving. Okay, so another person walking at constant speed travels the same distance to the bus stop in 200 seconds. Complete Figure 2 to show a distance time graph for this person. So they've got to go 500 metres in 200 seconds. There's going to be a point up there. And again, I take my nice quality ruler. It's worth having one for the exams. It'll give you a lot more confidence in some of the scrappy bits of plastic that some of you use. A nice neat line done like that through the origin. And that is constant speed. That gets the mark. If you do it freehand, the examiner may very well out of spite not give you the mark. A bus accelerates away from the bus stop at 2.5 metres per second square. The total mass of the bus and passengers is 14,000 kilograms. Calculate the resultant force needed to accelerate the bus and passengers. So the equation I need for this, Newton's second law, F equals ma, force is mass times acceleration. And in this instance, I just check the units. The mass is 14,000 kilograms, that's okay. The units is metres per second squared, that's okay. So I can say F equals, and you put the figures in. Now it's very important you do this, and you're not lazy and just try and do the whole thing on your calculator and leave it at that. It doesn't work well with the exam board. So 14,000 times 2.5, so 14,123 times 2.5 equals 35,000. And I'll put the answer where the answer is required. Right, everyone happy? So 35,000. So it then goes on to say the diagram shows a boat pulling a water skier. Frustratingly, it's put at the bottom of that page. And it says the arrow represents the force on the water produced by the engine propeller, and this force causes the boat to move. Explain why. And you have to write something like this. Let's put it in the right position for you. So the force from the engine is greater than the force from the water holding the boat back. So the boat moves forward. Or words to that effect. It's worth 2 marks. And if you look at the way I've answered it, I've given a statement that explains the answer. And that's something that you're all quite capable of doing. Some of you, on that sort of question, just says something. You just say things like, the boat goes faster. You don't do anything to explain why it goes faster, which is actually what they want. The boat accelerates at a constant rate in a straight line, and this causes the velocity of the water skier to increase from 4 to 16 metres per second in 8 seconds. Calculate the acceleration of the water skier and give the unit. So the equation we need is acceleration is v minus u divided by t. Now you have to know that. It's a stated equation that you have to be aware of. So let's put in my figures and see if this works. V is the final velocity, u is the initial velocity. So there's the final velocity, there's the initial velocity. So it's 16 minus 4 divided by 8. And again, you don't just do it in your head. I know you can. Equals 12 divided by 8. And I know if I use my calculator, that will be 1.5. It says give the unit. So when you're answering questions, it's a good idea to underline some of the key bits, just like I've done. And the unit is meters per second, meters per second squared. You can either do it like that, or it's meters per second per second. They will accept either one. So the next part, the water skier has a mass of 68 kilograms. Calculate the resultant force acting on the water skier whilst accelerating. Next formula, force equals mass times acceleration, F equals ma. We've just done the acceleration, it's here. And so force equals the mass, 68. Check it's no something silly, the units. No, it's kilograms is fine. Times 1.5 from there. Now, if you've done that calculation wrong, and you put it into this equation, but you do what I'm doing and you show you've put it in there, they will work it out what you should have got from using your number, and if that's correct, they will give you that. They will give you this mark. They won't penalise you between the two if you've got this bit wrong. So this is why I keep saying to you, for goodness sake, show you working out. So I have 68 times 1.5, 102 newtons. So please, will you get in the habit of writing your answers out like this? If you've got that wrong and you've done you've shown no working out here, because then that's going to be wrong, you get no marks. And a lot of these exams is just technique. Right, next question. It says, draw a ring around the correct answer and complete a sentence. The force from the boat pulling the water skier forwards, will it be less than, the same as, greater than the answer to part B, part 2? Well, part B, part 2 was the 102, and if that was the force being applied, the boat wouldn't go anywhere. So the force from the boat pulling the water skier forwards has to be greater than the answer to part B, and the reason is the engine force, or the force from the boat, must be greater than the force holding the boat back, or words to that effect. So you've got to explain why it's greater than. We just worked out that it was 102 here. The resultant force acting on the water skier whilst accelerating 102, you see. So we've got to have the engine force greater to keep that accelerating. So we now move on down. Some students designed and built an electric powered go-kart. The go-kart is shown below. Suggest 2 changes that could be made to the design of the go-kart to increase its top speed. There are several common sense things you can do here. We could streamline the car. How? By changing its shape. You can't just put 2 words and expect the examiner to give you the marks. We could use a more powerful motor. A third one we could do, you're not asked for it, but we could reduce the mass. So that's the sort of way you're going to answer that part of it. And then the go-kart with a new design is entered into a race. The velocity time graph of the go-kart during the first 40 seconds of the race is shown below. Between which 2 points did the go-kart have the greatest acceleration? Tick one box. Well, I know it's A to B, and the reason it is because if you look between A and B, it goes 5 meters per second in a very short time period compared, say, to the others. So the reason my answer it goes the greatest speed, the greatest speed in the shortest time. Okay? to the next part. The go-kart travels at a speed of 13 meters per second between points D and E. Calculate the momentum of the go-kart and the driver between points D and E. So we're given the mass. So the momentum, another equation, is mass times velocity. You have to know that. So it equals m times v. The mass is 140 kilograms, check its unit. The velocity is 30 meters per second, check its unit. So I simply need to go momentum equals 140 times 13. Get my trusty calculator. I actually got a thunderstorm starting as I do this, in case you're wondering what the flashes are on the paper. So just start again. 140 times 13 equals 1820 kilograms meters per second. And that's how you get that one. Total of six marks. And that is it. That's question 3. Well done.